So far, we've discussed 3 different ways you can solve quadratic equations: factoring, taking the square root, completing the square. Today, I'm going to give you our 4th and final method, which is the quadratic formula. I have it right here on the screen. This is basically a formula that tells us the solution to any quadratic equation. So it works no matter what kind of quadratic equation you have. In this class, you do not need to memorize this formula. It will be given to you on the final exam. However, in Math 121, you will be expected to memorize this formula. I think the reason we don't require you to memorize it here is because we're so close to the end of the semester and the final exam. You really don't have enough time to get it kind of committed to memory. But Math 121 will expect you to have this formula down. So I want to show you how the formula works. The basic idea is you have to put your equation in this standard or general form, which means you have to have one side equal to 0. Then the a is the number in front of the x squared, b is the number in front of the x, and c is the constant. All those numbers get plugged into your formula, and you can do some number crunching to get the answer. So in example 1a, first thing I have to do is set one side to 0. So I'm going to have to subtract the 4, and now this is in that general form. A is the number in front of the x squared, so that would be 1. B is the number in front of the x, and c is the constant. So now I can take these numbers and plug them into my formula. X equals negative 3 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. We now have to simplify, so this is a positive 3 plus or minus the square root of 9 minus 4 times 1 times minus 4. That's going to be a plus 16 over 2. So x equals 3 plus or minus square root of 25 over 2. And we can actually go even further because root 25 is 5. All right, so then 3 plus 5 divided by 2, that's 8 over 2, or 4. And 3 minus 5 over 2, that's negative 2 over 2, or negative 1. So I've got 2 solutions, 4 and negative 1. Let's do another example. So first thing we have to do is set one side to 0. So I'm going to minus the x minus the 8. That gives me 2x squared minus x minus 5 equals 0. So that means my a is 2, the b is negative 1, and the c is negative 5. Plugging that into my quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So that would be a positive 1 plus or minus 1. Once again, we got a minus and a minus, so that becomes a plus. 4 times 2 times 5 is 40, all over 4. Or 1 plus or minus square root of 41 over 4. 41 is not a perfect square. It doesn't have any perfect square factors. So that would be my final answer. So the quadratic formula is a great method because it's a formula that always works. You can plug and chug and get the correct answer. However, it's not always the fastest way to solve a quadratic. And so the next thing I want to do is talk about all the different methods we've talked about. And when do you use each method? So I think the first thing you should ask yourself is there only one term with a variable? So just count the number of x's. If there's only one place where you see an x, you'll be able to just use that square root method. Isolate the square root, or isolate the squared, take the square root of both sides. The second thing I would check is, can you factor? If so, that's a really fast method to use. If your answer is no to both those questions, if you can't factor or factoring's taking you more than 5 minutes, then I would use the quadratic formula. Of course, you can always use completing the square, but I typically don't use that method unless it says to use it in the directions. As you'll see in Math 121, completing the square is used in other types of applications, and that's why we talk about it here. But in terms of solving equations, for most people, the quadratic formula is a little bit faster. So the directions here say solve using any method. So A, can I take the square root? The answer is no, because I have two terms with x's in them. So if I were to get the x squared by itself, I would still have x's on the other side. I wouldn't actually be solving. So no to the first question. But then for the second question, let's see, can we factor? Well, actually, I think we can. It would be an x and an x. Product of 1 is 1 and 1. If they're both plus signs, that does add up to 2. So if x plus 1 is 0, x equals negative 1. And we don't have to write that down twice. The two factors are the same, so they give us the same solution. Now, we could have used the formula, but it would have been a lot slower than simply recognizing that it has to be negative 1. Example B, can I use the square root method? I see only one term with an x in it, so yes, we can use the square root method. So I have to isolate the x squared. I do that by adding 8 to both sides. Then I divide both sides by 4. So x squared is 2. Now we take the square root of both sides. Don't forget the plus or minus. So x equals plus or minus square root of 2. Example C. Can we use the square root method on this one? No, because there's an x squared and an x. There's two terms with x. So then the next thing I would try is factoring. Can I factor? Yes, I can pull out an x, and I'm left with 3x minus 4. So that means x could equal 0, or 3x minus 4 could equal 0. Add the 4, divide by 3. So I've got two answers, 4/3 and 0. And finally, in our last example, can we use the square root method? I see only one x in this problem, so yes, I can. I'm going to start by taking the square root of both sides. Don't forget the plus or minus. In this one, we're taking the square root of a negative, so there's actually no solution here. Or more specifically, there's no real solution. If we want, or if we're asked to, we could write our answer using that imaginary unit I. So x minus 5 equals plus or minus. Square root of 25 is 5. Square root of negative 1 is I. And then to finish, I add the 5. So x is plus or minus 5 plus 5i. Again, those are not real solutions. Those are solutions in that complex number system. Finally, we can use these same methods to solve what we call quadratic type equations. So technically, my examples in example 3 are not quadratic because they don't have x squareds in them. They have an x to the 4th, and then, there we go, x to the 4th, and the other one has an x to the 6th. However, these are considered quadratic type equations because the x to the 4th is an x squared squared. And the x to the 6th is an x to the 3rd squared. The largest exponent is the other exponent doubled. In other words, these are quadratic type equations because we can also factor them or even use the quadratic formula. I would definitely try to factor first. It's going to be a lot easier to factor these things. We briefly talked about factoring stuff like this back at the beginning of the semester. And the idea was if you have an x to the 4th, your first terms are going to be x squared and x squared. And then product of 4, I would try 4 and 1. If you make them both negative, that adds up to negative 5. You can actually factor this further. The x squared minus 4 is x plus 2, x minus 2. And the x squared minus 1 becomes x plus 1, x minus 1. And so that means you have 4 solutions. Negative 2, positive 2, negative 1, and positive 1. Now, you actually didn't have to factor your differences of perfect squares. You could have also set the x squared minus 4 equal to 0, added the 4, and taken the square root, but don't forget that plus or minus. That would give you your 2 and your negative 2. And if x squared minus 1 equals 0, x squared is 1. So x is plus or minus square root of 1, or plus or minus 1. So quadratic type equations, this should actually say equations here. Quadratic type equations can also be solved by factoring. So example B, same process, different equation. I'm going to start by trying to factor. So I have an x to the 6th, so this time it's going to be an x to the 3rd and an x to the 3rd. Remember, we add the exponents when we multiply, so x to the 3 times x to the 3 is x to the 6. And then product of 3 is 3 times 1. If it's a minus 3 and a plus 1, that does add up to negative 2. And then I would just set the factors equal to 0 on this one. And so let's see, x cubed could equal 3, which means x would be the cube root of 3. You don't need the plus or minus when you take the cube root of an equation. And that has to do with the fact that there's only one number that you can cube to get a 3. If your answer was negative, when you cube it, you would get a negative. So you only need the plus or minus with the square roots. All right, if x to the 3rd plus 1 is 0, x to the 3rd is negative 1, x is the cube root of negative 1, and that is actually negative 1. Negative 1 to the 3rd is negative 1. So I've got two answers, cube root of 3 and negative 1. All right, that's it for this lesson. Please let me know if you have any questions.